Hi guys, in this video we will be covering lesson 6.7 in your math textbook on page 253, and it is comparing fractions, and our essential question is how can you compare fractions? And so in our last lesson we talked about comparing fractions using benchmarks such as 0, 1/2, and 1, and so we're going to talk about a different way today to compare some different fractions. Our Unlock the Problem says, every year Avery School has a fair. This year, 3/8 of the booths had face painting and 1/4 of the booths had sand art. Were there more booths with face painting or sand art? So we have two fractions that we have to compare, and they are 3/8 and 1/4. And so it tells us here that what we're to do is to compare 3/8 and 1/4. So one of the ways that we can do that is by using a common denominator. And remember that the numerator is the number on the top and the denominator is the number that is on the bottom in a fraction. So when two fractions have the same denominator, they have equal sized parts, and you can compare the number of parts. And so in this problem, we need to think 8 is a multiple of both 4 and 8. And so 3/8 already has 8 as a denominator. So if we can change 1/4 to have a denominator of 8, then we can make comparing those two fractions much easier. And so when we change the denominator of a fraction, we must do the same. We must perform the same function. We must multiply the same number times the numerator and times the denominator. And so we say in order to get 8, we have to multiply 4 times 2. So 4 times 2 gives us 8. We also have to multiply our numerator by 2. So 1 times 2 is 2. So 2/8 is equivalent to, is exactly the same as 1/4. And now we have two fractions that we can compare, and they both have the same number of parts. They both have 8s. And so first we can shade in our model, 3/8. So we would shade in 1, 2, 3 parts on this one. And over here, we're going to shade in 2 parts. Now, I know you're probably thinking, well, we already know that 3 is greater than 2, so this is easy and we shouldn't have to use that shaded part. And so if you're thinking that, that's great. So you already know that 3/8 is greater than 2/8. Because when our denominators are the same, all we have to do is compare the top number, which is the numerator. Okay? All right, so here's another way that we can do this. Sometimes it doesn't work out easily for us to find common denominators. And so we can also use a common numerator. Remember, a numerator is the number on the top of a fraction. And so when two fractions have the same numerator, they represent the same number of parts. And so then you can compare the size of those parts. And so if we think here that 3 is a multiple of both 3 and 1, then we can use 3 as a common numerator. And so 3/8 already has a 3 as a numerator. And if we change the numerator for 1/4 to 3, then we have to do the same thing to the numerator that we do to the denominator. And so in order to get 3 as a numerator for 1/4, we have to multiply the numerator by 3. 1 times 3 gives us 3 as a numerator. And so we have to do exactly the same thing. We have to perform the same multiplication function to the denominator. 4 times 3 is 12. And so 3/12 is the same as 1/4. And so now we have two fractions that have the same numerator but different denominators. And this may help. This probably would help more with a model so that we can actually see that 8s are larger parts than 12s. Okay, if you divide something into 12 parts, the parts are going to be much smaller than if you divide it into 8s. And so we're going to shade 3/8 over here. And we're going to shade 3/12 on this side. So by doing this shading, you can see that 2/8 and 3/12 are equivalent. And so 2/8 and 3/12 are equivalent. And so 3/8 is going to be greater than 3/12. And since 3/8 is greater than 1/4, there were more booths with face painting. Good job. Okay, our next video will be on page 254.